Hi, so I'm making this video because I got a lot of these requests from the community where they are saying that MTrack is nice if it can actually do the tracking correctly without making mistakes. However, it would be nice if you could have the second module of MTrack, which is doing the Ransac fits, directly fitting on the kymographs which comes out of the MultiKymograph tool. And so this MTrack, just to give you a background, is the plugin which I wrote in 2018. It was to measure the dynamic endpoints of the microtubules, and the microtubules are these filament-like objects which are growing and shrinking, and the point is to calculate the growth shrink rates and the dynamic instability parameters. And classically it's done by having these kind of kymographs which are drawn by the MultiKymograph tool, and it's a very inaccurate way of measuring the dynamic instability parameters. So MTrack was supposed to replace this by doing this, by constructing these kind of kymographs at sub-pixel accuracy, which it does. However, if you have regions where the microtubules are overlapping, then kind of you have a segmentation inaccuracy going inside tracking inaccuracy, and you won't be able to get a very good read for these kind of microtubules. So the request that comes to me often is that people want to use not the kymographs which I make from MTrack, but they want to use the kymograph which they can get from MultiKymograph tool, but then they want to use the Ransac based fits on those kymographs and get these kind of reads automatically for all the experiments. Now the problem with that is that for this kind of fits, I just need the kind of extract these boundary points, right? And these boundary points are what I need to then have in like a CSV file which I can load in my program, and then I can say, okay, this is the length, this is the time, do the fit. Since the signal to noise ratio of such images is very low, I can do a lot of simple computer vision based operations like put a Gaussian blur, get the edges, and you will get spurious edges, so it would not be very automatic. So I decided that let's keep it semi-automatic and let's use Napari. So what I did was made this new uh, Python based plugin, a Python based tool called pyfiji. And what pyfiji has is the kind of precursor tools which would be needed if you want to go into Fiji for some of these tools. For example, in this tool, what you are doing is loading your directory of kymograph images, and then you are using the shapes layer of Napari to make a path. So this shapes layer automatically pops up when you actually select one kymograph from the directory, and then you select on your path functionality of Napari, and then you draw this shape over your kymograph. So what I'm trying to do here is extract these boundary points, convert them into a CSV file, and load that CSV file into MTrack Ransac mode, where you can do then these automated fits to get the growth and the shrink rates. So once you have done your clicks, you can click the sparse points that you just made by using this save functionality, and it's going to save your sparse clicks over here. However, if you want a more accurate or if you want more interpolated result or more dense results, so you just click a little bit over here, and then you can fit a spline, and then you can actually save this instead of the sparse labels that you just saved. And it's going to overwrite your file, and it's going to save this in the new file, in the same file. And then the good thing about Napari is that it gives users the full control over if they want to remove some points, or if they want to add some of their own points, they can just simply remove these points as they like, and then they can add the points that they actually want. And then they can save this kymograph again, and it will overwrite the file and produce a new CSV file. Once you're done with one kymograph, you choose another image from your drop-down menu. You use the same add path functionality of Napari, and then you go click, click, click to extract these boundary points, save them as CSV. And what I'm going to do next is make a new update for MTrack, where it can use these CSV files for obtaining the shrink rate, the growth rates, the catastrophe and rescue frequency of the microtubules as automatically as MTrack Ransac is actually already doing. So yeah, this will enable you to use the MTrack Ransac mode for complicated cases where the microtubules actually overlap. And in Napari, you can just remove these points if the spline fits are not actually perfect. So this gives you a full control now. Now you have what people actually ask me for, which is to get this kind of automated fits like these ones, which come from MTrack module 1, but now without using MTrack module 1. And it's my suggestion that you could use this Napari plugin, but if you are happy to produce the CSV file in some other way, then that's also fine. What you have to do is, irrespective of what tool that you use, you have to actually make a file which has two columns, time versus length. The order doesn't matter, it could be increasing or decreasing order of time. And then once you have this time versus length, I'm going to make a module in my new update, next update of MTrack, which is going to take this CSV files and output you the kymographs. So stay tuned for the update and keep look out for MTrack update next, which is going to have this functionality of actually giving you the fits coming from your own kymograph than the kymographs which MTrack produces by automated tracking. So, thank you. See you around.